Today we're going to continue talking about chemical reactions, and in this video we're going to talk specifically about single replacement reactions. By the end of the video, you should be able to identify a single replacement reaction and use patterns to predict products of single replacement reactions and predict whether or not a single replacement reaction will occur. So let's talk about predicting products. In a single replacement reaction, an element and compound react. So remember, an element would be like one word on the paper, compound would be two words. So an element and a compound react to form a different element and compound. And here's what the common form looks like. You'll have one word, which I'm representing as A, and a compound, which is two words. So this would be BC together. So you have A plus BC. That's an element plus a compound. Yields a new element. So that would be like B. And a new compound, AC. Now, if you just look at that, you'll notice that in this case, the A and the B just swapped places. So the A was by itself, the B was with C, and after this reaction, the A and the B just switched places. So it's like one letter got replaced, the B got replaced with the A. So that's the basic form of a single replacement reaction. We call it a single replacement because just one of these letters is going to get replaced. Okay, now when you're predicting products for a single replacement reaction, these reactions don't always occur. So in order to figure out if the reaction occurs, you have to use what we call the activity series sheet. The key to keep in mind when you're looking at that activity series sheet is this phrase: like will replace like, metals replace metals, nonmetals replace nonmetals. Okay, so here's some examples. I think this will help the most. A metal in a compound is replaced by a more active metal. So take this example. Lithium plus zinc acetate yields what? You have to predict the product. You have to predict the stuff on the right side of the arrow. So how are you going to do it? Well, lithium is a metal. Sorry, the format got slightly shifted, but lithium is a metal. Zinc is a metal. And so lithium can replace, the question is, can lithium replace zinc in this case? In order to figure that out, we got to use our activity series. So these are listed from top to bottom in order of decreasing activity. So the most active stuff is on the top and the least active stuff is on the bottom. So in this case, you're taking something that is more active. Lithium is the more active one. And you're using that to replace zinc. Zinc is the less active one because it's lower on the list. So when that happens, when you're replacing something that is more active, so you're taking zinc and you're going to replace it with something that's more active, the reaction does occur. So you get zinc plus lithium acetate. I don't know why it shifted. I'm sorry for that. So yeah, lithium is more reactive than zinc, and so the reaction does occur. Let's look at another example. You've got copper plus aluminum sulfate, and you have to predict the products. Okay, so copper is a metal. Aluminum is a metal. Remember, like replaces like. So the question is, will copper replace aluminum or not? You have to look at the activity series sheet. In this case, aluminum is higher up than copper. That means aluminum is already more reactive. So you're not going to replace something that's more reactive with something that's less reactive. So in this case, there is no reaction. Copper is lower on the activity series, and therefore it's less reactive than aluminum. Okay, here's another example of a single replacement. Lead 2 carbonate plus barium yields what? Lead is a metal. Barium is a metal. So if this reaction does occur, you will swap out the barium with the lead. But we have to figure out, is barium more active than lead? Barium is higher on the list than lead. So yes, this reaction occurs, and you get barium carbonate plus lead. You may wonder what do we do with the Roman numeral 2? Barium already has a +2 charge. It's in the second column on the periodic table. The only reason we had to put the Roman numeral 2 there with lead is one of those transition metals, so it's that section that we typically skip on the periodic table. We don't give it a charge, so we don't worry about the 2 in this case. Yeah, no Roman numerals necessary there. Okay, now another example for single replacements that you need to know about. Hydrogen in water is replaced by a more active metal. So say that you have this reaction. Sodium plus water yields what? Well, water is H2O, which is hydrogen hydroxide. There's an H and there's an OH in water. The H is hydrogen, the OH is hydroxide. So whenever you see water, just go ahead and change it to its formal name. Water is not its formal name. Its formal name is hydrogen hydroxide. So now you've got it in the format where it's A plus BC. You've got one word plus these 2 words. That's why we do that switch. Okay, now, once you've changed water, the name water, into hydrogen hydroxide, you can actually predict. So sodium is a metal, and I just told you when in this type of reaction, the metal replaces the hydrogen. So sodium is higher up on the list than hydrogen, so there is going to be a switch. So what you'll get is sodium hydroxide plus hydrogen. Those will be the products of the reaction. All right, another case to know about. Hydrogen, when it's placed in acid, is replaced by a more active metal. So here's an example. Say you've got calcium plus, and notice this word has the word acid in it. So calcium plus phosphoric acid. So change that name, phosphoric acid. Anytime you see acid, there's a hydrogen there. So you just change the name to hydrogen at the beginning. Whenever you see acid, it's going to be hydrogen at the beginning, and then the beginning word, you're going to change the ending to ate. So hydrogen phosphate. Okay, so now the question is, calcium is a metal, and the hydrogen gets replaced by the more active metal. So once you've changed the acid name into its ionic name, hydrogen phosphate, calcium is higher on the list than hydrogen, so there is going to be a switch. And so now it's calcium phosphate plus hydrogen. Okay, I believe this is the last one to know about. So sometimes you're going to switch the nonmetal. So far, every example I've worked, we've taken one metal and switched it out for another metal. But a nonmetal can get replaced too. So a nonmetal in a compound is replaced by a more active nonmetal. Here's an example. Say you've got fluorine plus magnesium iodide. So fluorine is a nonmetal and iodine is a nonmetal. So the question is fluorine more active than iodine? Yes, fluorine is higher on the list than iodine. So there is going to be a switch. And when you do this, whatever the compound is, that's where you have 2 words. In the compound, you got to make sure the ending is "ide." So once we make the switch, instead of saying magnesium fluorine, we say magnesium fluoride. And whatever is the element, the where it's just one word all by itself, the ending needs to be the ending that it is on the periodic table. So this would be iodine. So we have magnesium fluoride plus iodine. So watch your endings. Make sure that nonmetals replace nonmetals. And that is the end of this video.